Today you will be looking at logarithm properties. If you recall what a logarithm is, a logarithm of base b of a positive number x satisfies for the following. So if the base of the log is greater than 0 and not equal to 1, then we can say log base b of x equals y if and only if b to the y power equals x. Now, I remember back in the day in school, my teacher would just tell me to memorize this with this, and it was always confusing. So if I can remember log of the base is some number, that's going to equal the exponent, or the base of the log is the same as the base of the exponent equals some number. The other thing you can think of is you can almost think of it in a swirl kind of fashion. If I were to take my logarithmic form and start at the base, go through the other side of the equal sign, I can see that base of the other side is the exponent equals some number, which is the same thing as this. Now, a natural logarithm is the inverse of y equals e to the x power. If you've forgotten what that e to the x power is, that's just Euler's number. It's like pi, it's irrational. It is also a logarithm of base e. So we can look at a natural logarithm with common log base e or just natural log x. It's ln, not in. So let's go over and look at some basic examples or some properties of logarithms. So if we look at the first one, I know log base b of 1 equals 0 because if I were to write it in exponential form, b to the 0 power does equal 1. If I look at number 2, log base b of b equals 1, it's like it cancels out because if I were to write it in exponential form, b to the first power, well, that just equals b, which is a true statement. The same thing is true for number 3. It's like because the base of the log matches the number adjacent to it, right? B to the x power, that equals b to the x power, which is a true statement. The same thing is true with number 4. It is written in exponential form. However, when we write it in logarithmic form, remember the base of the exponent is the same thing as the base of the log. And that's going to equal the other side, which equals the power of, base b. Which is a true statement. The same properties are also true with natural logs. If I put the little e in as the base, it is understood as always e, which is why it is not written there. We know e to the 0 power is just 1. E to the first power is the same thing as e. Right? If I were to write this guy in exponential form, e to the x power equals e to the x power. And the same thing is true for number 8. If we were to write that in logarithmic form, this tells me the base of the natural log. And I know it's natural log because it's base e, which is a true statement. Now let's look at another type of problem in which we are going to have to evaluate logs. The first thing I would do is I would set it equal to eggs, or question mark, or some unknown number. So log base 16 of 64 equals some number. The next thing we will do is we will write it in exponential form. Okay, so to write it in exponential form, remember the base of the log becomes the base of the power. So 16 to the x power equals 64. The next thing we're going to do is we're going to try to write it so it has the same base. So is there a number that I can change 16 and 64 to so that they have it as the same base? So we're going to write what same base is. Well, I know 16 is the same thing as 4 squared, and 64 is the same thing as 4 cubed. Okay, And then the next thing we do, because the bases match, we equate the powers. And here we get x is equal to 3/2. That's it. Take a minute or two and try these example u-tries. Hopefully you find for A to be 3, B -5, because remember if it's 1 over 32, the exponent is negative, and 8. We're going to look at some more properties of logarithms. Okay, so we have these product property. Remember in multiplication, that is the same thing as separating it with addition, and the same thing is true with natural logs. So if we look at our example here off to the right, because these numbers are all product, we can say natural log of 2 plus natural log of x plus natural log of y. If we look at quotient property, remember from back in the day, if you are dividing, then for logarithms, that means you're going to subtract. And the same thing is true with natural logs. So if we look at our example, because the fraction bar means divide by, we can say log x minus log 12. And then the last one is the power rule. Power rule, all that means if I have some log of some number raised to that power, I just bring the power in front of the log. And the same is true here. We're just going to drop the power in front of the log. So 4 log base 5 of x. If we look at our next type of problem, notice we're going to condense each logarithm and simplify. So the first thing I would do is I would look for if there are any numbers written in front of any logs, and that indicates power. So we can say log base 3 of x minus log base 3 of 7 to the second power. All that's left for us to do is to clean it up. We know subtraction with logarithms means division, and it is important you only write one log base 3, and we know 7 squared is 49. So our final answer, log base 3 of x over 49. If we look at B, we're going to follow the same steps. So notice we have no numbers in front of the logs, so we have no powers. We know the plus sign means product, so we can say log base 8 of 48 times 4/3, and then we just have to finish cleaning it up. If I put a 1 underneath the 48, we know 3 goes into 48 16 times, and we have log base 8 of 16 times 4, which is 64. Now, if we were to write this guy in exponential form, we would have 8 to what power equals 64, and our final answer is just 2. Now let's take a look at C. So notice we have a 3 in front of one of the natural logs, and that just means we're going to move the 3 up to the x as an exponent. So natural log of 6 minus natural log of x cubed minus natural log of 7. Now we're ready to condense. Anytime there is a subtraction sign, that value is going to go in the denominator of the fraction. Natural log of 6 over 7x cubed is our final answer. Now the other thing you can do is you can think of it as natural log of 6 over x cubed divided by 7. Well, how do you divide fractions? Well, you multiply by the reciprocal of the divisor. So natural log of 6 over x cubed times 1 over 7, and then you multiply straight across. So that is why the 7 is in the denominator. Take a minute and try these example u-tries. Okay, so for example u-tries, hopefully for A you found log base 4 of 15x squared, for B 1, and C natural log of x squared times the 4th root of y. Now, you could have left it as y to the 1/4 power, that is the same thing. In our next problem, notice it says we're going to expand each logarithm. The first thing we're going to do is we're going to look at the overall operation, what's going on. That giant fraction bar means division, so if you recall, dividing means to subtract. Okay, now remember, any time that you have something in the denominator, you need a subtraction. So when you expand log base 5 of xy, the biggest mistake that I will see students do is they will put log base 5x with a negative, but they'll put a plus log base 5 of y instead of a subtraction. And then for log base 5 of 125, I want you to think about it as log base 5 of 125 equals some number. So 5 to what power equals 125? Well, that is 3. So there is our final answer. If we look at B, notice we just have a bunch of variables raised to different powers, so we're going to stretch those as much as we can. Remember, product means to add. So we'll say log of x squared plus log of y squared plus log of z to the negative 1. And then, remember, if you have exponents, you're just going to drop those down in front of the logs they correspond to. So our final answer, 2 log x plus 2 log y minus log z. That's it. And if we look at C, notice we have a giant fraction bar, so that means subtraction. So natural log of 5xy minus natural log of 6. Now we can still stretch the 5xy, that's product, so all those values get plus. So natural log 5 plus natural log x plus natural log y minus natural log 6, and that's it. Take a minute or two and try the example you trace. Okay, so hopefully for A, you found log base 3 250 minus log base 337. For letter B, 2 plus 5 log base 3x, because log base 3 of 9 is 2. And for C, natural log 6 plus 2 natural log x plus 3. Remember, the natural log of E is just 1, so that's like 3 times 1. Yay, time to practice. The end.